everyone, I'm Moulya.
I'm Samartha Raghav Prasad.
And I'm Samartha Narayan.
We are studying in 9th grade, Excel Public School, Koorgalli, Mysore.
According to the census, there were 3.5 lakh accidents in 2020, in which 1.35 lakh people died and 3.4 lakh were injured. The government of India has a vision to reduce road accidents by 50% by 2020. Our transport ministry has highlighted the issue of drowsy driving, because drowsy driving is responsible for 20% of accidents. According to their report, any commercial driver should not drive for more than 8 hours a day. It states that improper rest and continuous driving results in accidents. To implement the above condition, we came up with an idea of a device, an intelligent driver companion. It is an AI-based device that detects alcohol levels, eye blinking, and the duration of driving.
The system will alert the driver and the co-passengers if the eye blinking is lower than the eye aspect ratio for a while, and the driver time is longer than 8 hours. It will also alert if the driver has a high alcohol concentration. We implemented this solution using an alcohol sensor, a Raspberry Pi microcomputer, and an Arduino Uno. The code has been developed using Python and OpenCV to recognize faces and detect drowsiness using a camera.
The face recognition program captures the face and compares it with the registered faces in the database. If the driver's face is not matched, the code detects the face as unknown, and the alarm starts to ring. As mentioned before, a driver is not supposed to drive for more than 8 hours. The code checks the face every 15 minutes for 8 hours to make sure it's the same driver. If the same driver is still driving after 8 hours, a voice alert is sent.
Eye blink code captures the frames of the eye blinking, compares with the eye aspect ratio for 30 frames. If he is either drowsy or sleepy, an alarm is played to alert him. The alcohol sensor is connected to the Arduino board with a buzzer. If alcohol is detected in the driver's breath, the program will caution the driver and passengers through an alarm. All these three codes have been integrated into our device and have been implemented in this model vehicle.
I did most of the programming work, while Moulya did the research and the documentation.
I worked on building the model and extended my support in documentation. If we are selected for the next round, we will enhance the application by training the AI engine, which will improve its accuracy. Additionally, we will collect real-time data in order to identify the errors and fix them. We will develop a cloud-based pipeline so all data can be stored in the cloud. This is an advantage because the government can easily track every traffic violation committed by the driver. We will make our device small and portable so it can fit into all types of existing vehicles. Thank you.